My name is Lucas Plabst, and I'm a PhD candidate in computer science at the Colorado State University and the University of Würzburg. I will be presenting our work on multimodal interaction techniques for notifications in augmented reality on behalf of my co-authors, Florian Niebling from the TH Köln, Sebastian Oberdörfer from the University of Würzburg, and Francisco Ortega from the Colorado State University.
Notifications play a huge role in daily computing, with an average of 200 a day, and in some extreme cases even up to 5,000 a day. Turning them off may lead to a higher reported productivity, but also to a feeling of being disconnected. Notifications are also not always strictly informative, but might require a certain interaction.
So maybe we can use augmented reality to help with these notifications. Janaka et al. Have demonstrated that messaging using an augmented reality head-mounted display showed better multitasking capabilities and faster response times than using a smartphone, and suggest that even now the usage of an HMD as a supplemental device to the phone can improve messaging during multitasking. Kosh et al. Evaluated 3 AR notification selection techniques while cycling: gaze with a dwell time, gestures, and gaze for indication with a physical button press for confirmation. They found that gaze with dwell time resulted in the lowest error rates, but required more attention and focus, whereas the gaze with button approach was preferred by users and had the lowest task completion time. In our own previous work, we investigated various display types for multiple notifications in augmented reality, along with unimodal interaction techniques. Our findings indicated that touch outperforms voice or gaze interaction, and that participants favored having a notification list attached to their hands rather than in the surrounding environment. In this work, we researched how we can interact with notifications in AR using multimodal interaction. Especially because notifications are usually short-lived, interaction needs to be quick, easy, and not distracting. For this reason, we set out to answer 2 research questions. Question 1. Is the user's perceived usability of notifications influenced by the interaction technique? And question 2, is the primary task performance influenced by the interaction technique of notifications?
For this experiment, we used a simulated cooking task running on the Microsoft HoloLens 2. In this kitchen environment, users had to prepare food for customers, either coffee, pizza, or burgers. In total, 6 customer orders had to be prepared, 2 of each food item in a random order. Ingredients for each food item were randomized. Orders, or cooking updates, were presented as notifications that could or had to be interacted with. Notifications had a dark gray background, a white text, a white icon, and a blue button. Selecting this button would either acknowledge that a new order was started or dismiss the notification if it was just an update notification. The notifications were presented in the bottom center of the user's field of view, in line with our previous work about notification position. The notifications also had a sound upon delivery, which has been shown to improve recognition of the notification. In our previous experiment, we found that touch outperformed unimodal voice and unimodal gaze input. So what happens if we combine things? We split the interaction components up between modalities into indication and confirmation. Indication was done using either gaze or point. With gaze, a button could be indicated by simply looking at it. With point, the button was indicated by pointing at it with the index finger. For confirmation, we used a pinch gesture or a speech command. For pinching, users needed to tap their index finger and thumb together. For speech, the word select had to be said out loud. To compare multimodal techniques to our previous work, we included touch as a control condition, since it performed the best previously. For the experiment, we used a within-subjects design with one independent variable, interaction technique. We recruited 27 participants from a university campus aged between 19 and 34 years old, with a mean age of 24. 17 of the participants were male, 9 female, and 1 other. We measured task performance, as well as subjective measurements such as system usability using the System Usability Scale questionnaire, task load using the raw NASA Task Load Index questionnaire, and a preference ranking using the board account method with a freeform text justification. Starting with the performance measures, we found that the time until an order was accepted, so the time from the customer arriving to the time the actual order was started by the participant was significantly shorter for touch than for point and pinch or gaze and speech. The total time it took to complete all 6 orders showed a significant main effect, but no conclusive pairwise comparisons could be made. The amount of incorrect orders, so the amount of times the wrong order was made and then confirmed to be ready, was significantly higher for gaze and pinch compared to touch, gaze and speech, or point and speech. Finally, the time per customer order and the amount of orders that expired since it wasn't ready after 2 minutes showed no differences between conditions. Moving on to subjective measures. The NASA TLX showed a significant effect in the physical demand subscale, but no effect on overall task load or any other subscale was found. Within the physical demand subscale, no significant pairwise differences were found, however. As for usability, the System Usability Scale questionnaire showed a significant main effect, but again, no pairwise differences. It is worth noting, however, that due to how the SUS is scored, a value over 68 means that it has above average usability. In our experiment, only touch managed to score higher than 68, with a mean score of 72.8. Finally, we asked participants to rank their favorite techniques from most to least favorite and assign point values to each ranking. We found that gaze and speech was ranked significantly lower than all others. Looking into the justifications for the preference, we could identify several themes. The greatest concern we found was the perceived reliability of modalities. The latency between the processing of both modalities happening at the sensor fusion led to low perceived reliability. Sometimes, by the time that one modality confirmed the button, the other was no longer indicating the target, causing the interaction to fail. The participants also mostly did not report on the entire techniques, but rather on individual modalities, like for example, not liking speech entirely over not liking specific interaction techniques with speech. Another issue, but still related to reliability, was that participants found the pinch gesture too hard to perform. Some previous work found that the pinch gesture they used in their experiment was too easy to perform on accident. But in our case, we see that it is also important to not make it too hard and overcorrect. Lastly, touch was again well liked in the comments, but it did not rank significantly higher than others. Some issues with touch, however, were reported, mostly that participants had to extend their arm too much to hit the button. We can draw several conclusions. First, multimodality closed the gap to touch interaction, where unimodal techniques were outperformed by it. However, touch is still very fast and easy to use, and was not outperformed in our experiment either. Systems should let the users customize the interface, however, by changing things like distance or size to better facilitate touch interaction. Second, when using multimodal interaction, the system should prioritize the reliability of the modalities, ensuring consistent interaction. Safeguards should be implemented to optimize interaction, like potentially saving the last indicated target for a short time after it is no longer being indicated. Lastly, the user should be able to choose which technique they want to use, or be given the option to use several at once, allowing flexibility depending on the current circumstances. Our work had some limitations. First of all, the HoloLens 2 might not have a very large camera field of view, causing the hand tracking to be inaccurate sometimes. Also, it is no longer the fastest, which could contribute to the latency of the modalities. The second limitation was that our notifications only had one action that could be performed, whereas in most operating systems, notifications feature 2 notification actions, one dismissing the notification, and second opening the corresponding source. In the future, we would like to research a cooking task with real objects, include more interactions like quick replies, and allow the user to use all techniques at the same time and study the situations in which they choose to use certain ones over others. Thank you very much for your attention, and if you want to contact me or the authors, please find the contact information on this slide.